Hi everyone, in this lecture I will teach you that how you can design an antenna in CST Studio. So I will go to the new template, I will click on microwave and RF opticals, and then I will select the antenna and I will go to the next. Since I am going to design the patch antenna, so I will select the plane or patch surface, click on next, and this is a time domain. Go to the next, these are the units, click on the next, and these are the frequencies. I will later on rectify them, change them. So click on the next, and now this is the window where I will create the geometry of the antenna. So here I am going to design a microstrip patch antenna. So I will go to the slide to see the detail of the microstrip patch antenna. So I'm going to open the slide, and these are the different dimensions and shapes. You can see that this is a microstrip patch antenna with the feed. Then we have a substrate. This is the patch. Then this is the substrate, which is in black color. And below the substrate we have a ground plane. And you can see that the patch is above the substrate and the ground plane is below the substrate. So again, we should note that the orientation of different geometries within this microstrip patch antenna. The patch is above this substrate and the ground plane is below this substrate. So first we have a patch, then a substrate, then a ground plane. And we can see here, this is the microstrip feed where the signal is fed to the patch antenna. So this is the feeding point, or we can see this is the feed line. So now we will go to this slide. This slide, we can see that this is the substrate, this one is the patch, and this one is the ground plane. So we have the substrate, which is FR4, and its thickness is 1.57 millimeter, and its width is 50. I can write it as 50. So this is the patch with PW is 36, and as we know that the substrate is made of FR4, we should note that the FR4 is a substrate material. We will assign it in the CST Studio then. And we should note that the thickness is in millimeter, which is 1.57 millimeter. So this is the substrate material with the dimension and details given. So in the CST Studio, I will first design the substrate geometry in the of the antenna. So we will go to the CST Studio, and here in this environment, I will go to modeling, and I will then select the brick. So here in the modeling section, you can see that there are different shapes available. One is brick, the other is sphere, the other one is the torus. Then we have some further more shapes available, which is cylinder and elliptical. So we have different shapes available. If we have to design any helical antenna, then we can choose any shape from this. And this one is the pix. If we have to pick the face, then we can press 5. So follow my step, then you will be able to learn all these techniques. So now up to this point, I will go to the modeling section, and in the modeling section I'm going to design the substrate. So I will select the brick because the brick is suitable for this shape. So press ESC, and you can see that the properties are now visible. So I will write the substrate in the name, and in the X-min I will write the dimension value. Since the W is 50, width is 50, and the length is 56, so I will write in the X-max I will write W, and in the Y-min in the Y-max I will write L. In the Z-max I will look into the shape. You can see that this substrate has some height. So I will have to define this height as well, because substrate has some height, it has some thickness, so I will define the thickness here. I'm going to write st here by defining a variable. Now I need to pick some material for the substrate. As I know that the material is made of FR4, so I will select the FR4. So this is the FR4 material. I will load this for the substrate. Different material have different permittivity and permeability, but I am using the FR4. So I will load it, and now I will click on the preview. Since the width of this substrate is 50, here W equal to 50 millimeter. So I will go and I will write it here as 50, and I will define the description as width of the substrate. So I will write width of substrates here, and I'll press OK. Since the length is 56, so I will write 56, and I will write length of the substrate. So I will write length of substrate here in the description section. Then I will press OK. Since I have some thickness of the substrate here, the thickness is 1.57 millimeter. So I will write 1.57 millimeter here, and I will write the thickness of substrate. So I will click on the OK, and you can see that the substrate geometry has been created, and these are different variables which have been defined. After defining the geometry parameter, you need to press the space button on the keyboard. This button, this is a space button. You need to press this button on the keyboard. So when you press the space button on the keyboard and press OK, you can see that the geometry is now visible in the window. Now as you can see that this geometry of the substrate that we have created is not at the origin. It is in the positive XY plane. So we need to shift this geometry of the substrate to the origin. So for that we need to select the substrate from the components. So we will select the substrate, because for the geometry need to be at the origin, because if we need to translate or drag it to some place, it will be easy for us. So we need to redefine these parameters. So we will change the x min, and we will change the x min to minus w by 2. So we will write here minus w by 2, and in the x max we will write w divided by 2. Now for the y-axis we will write minus l by 2, and for the y max we will write plus l divided by 2. And here at the z max we will not make any changes. So you can see that after clicking on the preview, we can see that the geometry is now at the origin. After defining the substrate, we will press on the space button so that this geometry is visible in the workspace. So we will double click on the space button. Now the geometry is visible to us. Now we can re-verify the dimension of the this substrate. So for that we need to use the two keyboard button, which is S and D. S is for the selection and D is for the deselection. So now we will press S, and wherever we click on the substrate, that face will be selected. So now we are going to verify the dimension of this side. So it tells us the length of this is 56. We can press D to deselect this side, and then again we can press S to select any other face of the substrate. So through this way we can verify the dimension of the substrate. Now here we can see that the width is 50, and if we need to verify the height, we will rotate this and we will zoom it so that the z-axis should be visible to us. First we will drag it, then we will rotate it slightly, then we will zoom it so that the z-axis is visible to us. Now we will press S again and we will click on this side, and we can see that it is 1.57 millimeter. So this is the thickness of the substrate. Now we have defined the complete geometry and we have verified the dimensionality of the substrate. Now we need to design this patch. So to design this patch, we will go again to the modeling section and we will select the brick and we will write it patch. The name of this geometry will be patch. And as we know that the PW is 36, so the patch width is 36 and the patch length is 28. So we will write the patch width here. So we will write 0 here, and in the maximum Xmax size we will write PW. Similarly, in the Ymin will be 0 and the Ymax will be PL, which is the patch length. And for the Zmax it will be CT, which is the copper thickness. And the copper thickness here we will define. The copper thickness is, first I will load the material. I will go to the material and I will write copper here so that the copper properties should be assigned to the patch brick which we have created. Since the PW here is 36, so I will write 36 here, and I will write the length is 28, so I will write 28 here. In the description I can write the patch length. I will click on the OK. Now the last parameter, which is thickness, so we will write 0.035 here, and this is the patch thickness, or we can write thickness of patch here. So we will click on OK, and you can see that we have created the patch, but we see that the patch is not at the proper position, so we need to align it to the center. So we will write minus PW by 2 here in the Xmin position, and in the Xmax we will write PW by 2. In the Ymin we will write minus PL by 2, and in the Ymax we will write PL divided by 2. So when we click on the preview, now we can see that the patch has been defined, but the patch is below the substrate. We need to put the patch above the substrate. So for that we need to change the Z min value. We will write ST in the Z min, and we will write CT plus ST in the Z max. As we know that ST was the substrate thickness, so the patch is now shifted to the top of the substrate. Now we have defined the patch and the substrate. We can verify its dimension. Just press on S, select the side, select the face, and you will see the detail of it. Like this side is 36, and you can see the thickness. You need to zoom it so that the z-axis might be visible. Now you can see that this is the z-axis, so we will press on S and we will click on this side, and you can see that it is 0.035 millimeter. So this is the copper material with the thickness of 0.035 millimeter. Now as we have defined the substrate and we have also defined the patch, now we need to define some further objects to complete the design of the microstrip patch antenna. So we will see the details. So this is the feed point, and the feed point is connected to the page, and we can see that f of t is 14 and w of t is 2. So we can write the feed. This is the feed, so we will write fw here. Fw is 2 and fl is 14. So these are the variables which we have defined. We'll go again to the brick, and we will select the brick, and we will write feed here in the name section. So feed line, and in the xmin we will write the name of the variable, which is feed width divided by 2, and the xmax will be the feed width divided by 2. So the xmin should be minus fw by 2. So first we will select the middle point. We need to define it here in the middle point. So we will click on this, and we will zoom it so that we will need to identify the middle point of this page. So we will click on M, and then you can see that we have selected the middle point of this page. Press on W, so that after pressing the M, then press W, so that we may shift the origin to that point. Now you can see that the origin is at the middle of the width of the page. Now we need to go to the brick which we have to create for the feed line. So we will write the feed line, and we will write the feed line length as fw divided by 2. We will write minus sign, and we will write fw divided by 2. We will write in the ymin we will write 0, and in the ymax we will write minus 6, since the length of the feed line should reaches to the substrate edge. So we will write minus 6, then we can change it further, and the thickness would be the CT, which is already defined in the parameter list, and the material of this would also be copper. So the copper is already loaded here. So we will press on the preview. As we know that the feed width is 2, so we will write 2 here, and we know that the feed length is 14, so we will write 14 there. First we will write the description of the feed width here, and then in the FL section we will write 14 because this is the length of the feed, and in the description we will write the feed length. After that, after defining the feed line, we will click on the preview, and you can see that the feed line has been created. Now click on this option, and you can see that now we need to join the feed and the patch. We need to join them both of them should be connected. If we look into this, we can see that the feed line is slightly above the patch, so we need them to be aligned along the z-axis. So we will again go to the properties of the feed line, and we need to change this variable. I will write minus CW here, and now you can see that the feed is aligned to the page along z-axis, and there is no overlap or no variation in the z-axis properties. So we have now created the page, we have created a feed line, and we have created a substrate. Now we need to create the ground plane. For the ground plane, we will again use the same shape. You can see that the ground plane is below the substrate. The page was above the substrate, and the ground plane is below the substrate. So we will go again to the modeling, and in the modeling section we will again select the same shape, because the shape of the ground plane and the shape of the substrate is similar. So we will select, first we will join the feed and the patch. So for that we will select both of them, we will go to Boolean and then we will add. Now the patch and the feed line have been connected and it becomes single object. After joining the feed line and the patch, we will define the substrate. So we will go to the modeling and we will select the brick, and here we will write the ground plane. So we will write the ground plane here, and in the xmin and xmax we need to define the variables. So it is in the same size as the substrate, so we'll write minus w by 2 and plus w by 2, and the substrate length was L, so we will write minus L by 2 to plus L by 2. And for the Z max, we know that the thickness should be the thickness of the copper, CT, so we will write minus CT here because it should be below the substrate. Now when we click on the preview, we can see that the substrate is below the substrate is here. It is below the ground plane is below the substrate, and we can click on S to select the thickness and we can verify that it is 0.035 millimeter. Now we have defined all three components of this microstrip patch antenna. After defining all these microstrip patch antenna, we will click on the feed line, and here you can see that there is an option, and this is rename option. We will write it as patch. So we have now three components are available. One is the ground, other is the patch, and the third one is the substrate. Substrate is between the ground and the patch. Now we can also change the color of the different geometries. As we have seen in the slide, the color of the geometry is different, so we can change these color. The ground is blue, so we will click on the ground and we will right click on it and we will go to the change material and color, and here we will change the color. So we will select the this color, which is blue. So we can see that the color of the ground has changed now, and if we rotate it, we can see that the material color has been changed now. So now I will feed this page so that the simulation may be started. I will go to the simulation, and we have three options available. One is the waveguide port, other is the discrete port, and the third is the plane wave port. So in all of them I will be using the discrete port now because it is very easy. In order to feed, I will need to look into this side, which is the feed point. I will zoom it. Now we can see that the feed point, the feed side is visible to us. We will need to highlight or select the feed point. So we'll click on M so that the middle point of the feed side should be highlighted or selected. So now we will select the lower point of the feed line. There are two position, one is the top and other is the bottom. So we will select this lower one, and after that we will shift the origin to this point. So we'll click on W on the keyboard. When we click on W, the origin will shift to this point. You can see that the origin has shifted to this point. After that we will go to the simulation and we will click on the discrete port, and you can see that there are different parameters which we need to define. So I will write minus ST here. When I click on the preview, now you can see that the discrete port is directed from the ground plane to the page. So if I write plus ST here, then you can see that it is not accurate. It is from the air to the page now. So we'll write minus ST here, and I click on the preview. You can see that it is from the ground plane to the page. The impedance is 50, which is okay, and all other things are okay. So we'll click on OK now. Now we will remove this axis from here. We will go to modeling and we'll click on this option. Now the axis has been switched to its old position. Now you can see that we have designed a microstrip patch antenna in the CST Studio, and you have learned all the techniques and methods. So this is a very simple design. We will further explain to you more complex design. So we will save this design and we will write the name as patch antenna, so that this file patch antenna 1, so I will save it and the file of this antenna will be exported to my drive. So now we will start the simulation. For that we will go to the simulation and we will go to the home and we will click on the start simulation. Now we will define the frequency range. So the minimum frequency that we have choose is 1 and the maximum that we have choose is 10 gigahertz. So the resonant frequency which we have not defined is 2.5 gigahertz, and the operating frequency is 2.5 gigahertz for this design of the antenna. Now we will press on OK and the simulation had started. Since the simulation takes some time, so after the simulation get completed, the results are displayed. So we will discuss the simulation in the next lecture, and thank you so much.